Welcome back, everybody. Another day here in the garage working on the Cadet 100. So I went ahead, I took the V-belt off of the hydraulic pump just so we can get it down off the tractor, out of the way. Still have the hoses hooked up though, so for now that will just kind of sit there, but that gives us some room to get in there and look at that axle pivot pin. So I noticed there's some interesting things going on here with this front axle. Now, the first thing I noticed is that the pivot pin is moving with the axle, so it's turning, and I believe from looking at the parts book that should be fixed to the frame. So I think there's a roll pin right there you can see. So I'm thinking that roll pin may have sheared off and that pin is actually seized inside of the axle casting, and I think that's what's holding the pin in there, because other than that, I think that pin would just fall right out. So there might be a job to get that out, but we'll see. And my plan here is to take the front axle off. So I think I'll go ahead and disconnect the drag link from the steering box. So this connection right here, this ball joint is new. I replaced that about 2 years ago. Okay, I have the wheels turned hard to the left so I can get that ball joint off of that steering arm. And one thing I noticed while I was doing that, so I saw there's like a witness mark, kind of a point right here on the steering arm that looks pretty wore out. So what's happening is when the axle oscillates or pivots, it's actually making contact with this bolt head right here, and that bolt is what mounts the loader frame to the tractor. So there's a lock washer and a flat washer below that bolt head, so it's really sticking out there. And so I'm probably going to be replacing that to a lower profile head so that does not happen. But I didn't realize that the end of the threads here on the ball joint that stick up through this hole were also contacting that bolt. So I need to buy one of these as a replacement, because these threads are all flattened out at the top. So I'll go ahead and take this off anyway. You can buy these pretty easily online. All right, and then that will have to stay in there because I have it kind of pinched right now between the wood blocks and the loader frame. So I think those bolts are just a bit too long anyway. You can see they almost come in and touch the bottom of the engine block. So we'll probably put shorter ones in there, and I'll move the lock washer to the inside below the nut there, and that will give us some more clearance out there for this mounting bolt. All right, here's a better look here at the front end. So here's the pivot pin right in the middle. This collar is welded, I think, to this this frame cross member, and so this member here is actually welded to the bottom side of the tractor frame. So something else here I noticed, and I've never seen this before until right now, but on both sides, so I'm talking on the axle casting itself. Let me get the flashlight down here. You can see right there, right here, looks like a torch or a grinder wheel went through there, and there's even one right here. So I don't know why or how that would have got there, but probably get a better look at that once the axle's out. So, like I said, the next thing to do is to get this pin driven out. I don't know how bad that's seized in the axle casting. I might need to spray that with some penetrating oil, and I might even need to use some heat on the axle casting just to help expand that a bit. I'll try to dry that out with a hammer. So we'll give that a go and see what happens. All right, I'll show you here. There's definitely some wear back and forth on the axle. It's moving roughly probably 3/16 of an inch back and forth like that. The pin's definitely seized in the axle housing, which I suspected. And so this plate right here, which forms that cross member, it is bent and deflected quite a bit. And I've read that's not too uncommon on these narrow frame Cubs. You know, every time you hit something with the front end, the front wheels hit a bump, you know, you're putting a lot of shock load into a plate like that, and it just kind of bends that back. So we'll see how bad it really is. Hopefully this pin comes out, and we'll get a better look then. Well, I might have to go to plan B here right from the get-go. The issue is I can spray that pin all I want. It's sort of tough to get up in there where it goes through the axle to get a good spray up in there. But I don't think that's going to work here, and a hammer and punch just not going to be enough to drive that pin out. The other problem is there's nothing out here for me to jack from. So if I had a little hydraulic press, I could push on that pin, but again, there's nothing to push from. So I'm sort of stuck, I think. I might use a reciprocating saw with a metal blade to actually go up in there and make a cut. I'll push the axle to the back so it gives me the largest gap in the front. I'll make the cut there, I'll cut the pin, then I'll push the axle forward like that and make the cut in the back. The axle should come out then, and what's left of the pin in the axle, I can then try to dry that out with the hydraulic press. But I don't want to use a grinder. I'm in the garage here. Just too many things in here. Don't want to be putting sparks everywhere. So we'll give that reciprocating saw a try. I think that's our best bet. We'll see what happens. Okay, we got the front axle off the tractor. It wasn't too bad really, just made our 2 cuts, and I've not tried to push the pin out yet. We'll get to that one later, but I degreased everything, and I wanted to look at the condition of the spindle bores to know what I'm dealing with here. And really this front axle is not too bad, I think. Most of the wear is on the bottom side of the spindle casting, and that's basically where the spindle thrusts up against that inside edge. So that edge, it's probably hard to see on camera, but there's a little bit of a lip right there, so maybe I'll just file that back down so it's smooth. And the spindles themselves, I will not be reusing these on this build. I'm making custom spindles, but there's some typical wear there from where the wheel bearings ride. You can see right there. There was some pitting and corrosion on the horizontal part where the wheel goes. The upright, yeah, there was some wear there. Nothing too bad on the right hand side, but the left side, this is where the drag link connects from the steering gear box. This vertical shaft was so deformed and worn in the spindle, I had to use a hammer and actually drive that out. You can see that wear right there. And there's a pretty good lip right there that kind of shows you how far that has worn in. But like I said, I'm not reusing these, so we can put these aside for now. And I have my brand new axle pivot pin. So I bought this one online. I think the quality is okay. You can see right here where it's necked down in the middle, and that matches the original design of the pin. And this hole right here is for the cotter pin, which goes through the front bushing on the tractor. So this is the pin that we had to cut, and there's what's left of that one. But because it's the same size, it's just 3/4 inch round stock. I was using that sort of as a test gauge to judge how much wear there is in the spindle bores. And yeah, there's some. You know, it's really not horrible, but it's probably not like it was the day when it left the factory. I always thought these bores had bronze bushings in them, but I guess they don't. maybe some of the newer tractors, they started putting bronze bushings in there. But one thing I do want to do to this axle is I want to add a grease fitting on the bottom side right here. I'm sort of surprised that they didn't do that from the factory. The spindles are greased here, but that main pivot pin is not. And I think it wouldn't be too bad. I'll just drill a probably 1/8 inch hole straight through the middle of this casting, and I'll tap that and thread that for grease fitting. So when the grease gets pumped in there, it's going to fill up this void on this pin, and then eventually it will purge its way out each end of the pin and make its way out here and here. And that should just really cut down on the wear in the future at this connection. And thinking ahead, because I've not tried pushing this pin out yet, just in case I damage this axle, I was able to pick up a spare one. It's always good to have spares, I guess. But that way I can compare the wear between this original one and this new one, and then kind of make a decision on which one to use here. So real quick, using our same test gauge, I think the wear, it might be slightly less on this spare axle. This side's actually pretty tough to put this pin into. I think there might be a burr in there. But this is a really nice fit actually for the main pivot. So this pin's able to go in all the way. Sort of have to work it in there, but it does go through, and it seems like it's nice and tight. So maybe we'll end up using this axle, I'm not sure, but I still want to try to push this pin out, and we'll see what the condition of that bore is on the inside there. And last thing I'll point out here on these axles, sort of interesting, but they both have almost the same marks in that bottom flange. And at first I thought the axle I had, at some point somebody had ground through that or torched through it. But when I got this one, I noticed it was pretty much the same way. I'm not positive why that's like that. Maybe the mule drive bracket for the lawnmower hung down below, and as the axle pivoted back and forth over terrain, it wore its way through. I wouldn't think that's from a V-belt, or if that V-belt for the mower drive is even close to that point. That probably is pretty far out here, and the axle's back under there. So again, I'm not sure, but if you know why those marks are in there, feel free to leave a comment down below. And moving on, you see here we have some brand new parts starting to move into our custom build for these front hubs. I'll start here with the tire and rim. So as you can see, this is a tri-rib tire. It's a 4x8 tire. So it's roughly 4 inches wide, bead to bead, and 8 inches on the inside for an 8-inch rim. The tires are Airlock brand. I was deciding between the D-Stone tires and these Airlocks. I think those are the only two brands that make a tri-rib in a tire of this size. These had a slightly higher weight capacity than the D-Stones. These are 495 pound weight rating. So I went ahead and got them for something different. And the rim here, this is a 3 3/4 wide by 8-inch rim, and it's a 4-on-4 bolt pattern. It's a DOT approved rim meant for a small trailer, and that's just what I needed, so I can adapt a 4-on-4 hub so we can get these tires and rims on the Cub Cadet. So I mounted these myself. They were pretty tough. These tires are 4-ply, and the sidewall is pretty heavy and stiff. Those are some of the hardest tires I've ever mounted. I've mounted many of these 4x8 tires, some ag tires there, and then this kind of stud tread. But these ones, like I said, pretty tough to mount, but they did go on okay. I think they look pretty good. You can see it slightly stretches the tire, not very much. And at roughly 500 pounds per tire, that should be good enough for the Cub Cadet. And moving on now to the hub. This is a 4-on-4 hub meaning there are 4 studs on a 4-inch bolt circle. The studs are 1/2 inch. This is a cast iron type hub, very heavy duty. I searched around for a long time and I decided to go with this certain brand. These are cast and machined and assembled in the USA. So they come pre-assembled with the bearings already in them, the grease seals, and the studs pressed in. And last but not least, here is the spindle. This is a BT8 class spindle. Of course, it is compatible with the hub that I bought. This is a 1-inch bearing journal. So 1-inch diameter right here and 1¼ inches here in diameter. They make 2 versions of this. This one having the round profile back here. The other version is a square profile, and these are made also for trailers. You basically weld these onto the axle, and these are meant as replacement parts for trailers. And one more thing here about the hub. So it did come with this grease cap, and some of these come with the Easy Lube style cap. It's like a plastic cap, but I searched around and I'm kind of happy that this one came with a, looks like it's aluminum cap. So that yellow cap is just to protect the bearing right now and keep dirt out. That will come out. This cap will get pressed in, and eventually I'll paint this, I think, yellow. This will be yellow, and that will go into the white rim. And while these parts are sitting here, let's do a quick side-by-side comparison. Of course, here's the brand new tapered roller bearing that came out of the hub. Here's the original ball bearing that come factory on the Cadet tractors of this series. So just looking at the size there's quite a difference. Again, 3/4 inch ID versus 1-inch ID, and then just the all-around difference from a ball bearing to a tapered roller bearing gives quite the increase in load capacity. Here's a quick comparison of the spindles. So as you can see, much larger in diameter, obviously, but also much longer. So if I set those side by side like that, the other spindles, the new ones, are roughly 1 inch longer, helps get those bearings spread apart. Just an all-around, much heavier duty design. And I will say real quick, this is not my idea. I'm not the first person to adapt a 4x4 heavy-duty trailer hub to a garden tractor, but it is sort of up to you to figure out how to get this spindle to be compatible with the front end of that tractor. So of course this is pretty easy, just buy all the parts, the hub fits right in the rim, spindle fits right into the hub, but the challenge is going to be, how do we actually get this thing to end up down here on the tractor at the right width, and so everything works well and nothing breaks. That's going to be the challenge here, but I just wanted to say again, this has been done a lot, and I've seen it done both ways with this round stock design as well as the square stock. Here's a quick view with the spindle pressed into the hub. That last journal right there, that's where that grease seal rides. So it's a nice fit. You can hear that grease seal. So that's the plan. And this video is probably dragging out here. I don't want to make it too much longer, but just wanted to show you a quick mock-up of my plans here. So before I took the old tires off the tractor, I measured the tire gauge, which was center to center on the front tires. I got roughly 27 3/4 of an inch. So I'm trying to maintain that the best I can. So I have the spindle inserted into the hub here. The axle's mocked up approximately at the right height. I think it'll be a bit higher. But the plan is I'll need to get some 3/4 inch round stock, and that will form the vertical part of the new spindle. So I'll end up locating and drilling a hole through this piece of stock on the back of the spindle and pass the 3/4 inch shaft down through the spindle, straight through, or through the spindle bore, then through the spindle, and I'll probably have it come out the bottom, and I'll weld around the bottom and the top. Then whatever's left over on the inside here, I'll just cut off. And yeah, we'll see how it goes. But the hardest part, I think, is going to be locating a punch mark at the center of this and actually drilling a hole. So of course I'll start out small with a pilot bit, and I'll try to creep up on that 3/4 of an inch, and we'll see how it goes. That's probably gonna be the next video here. Again, this one's mostly just kind of talking and going over everything I've gotten in so far as parts and what the plans are. So anyway, I found out that I'm right at about 14 inches center of the tire to center of the axle, which is basically 1/8 longer than the original one. So as long as I can keep that 3/4 inch hole pretty close to that, the grease seal journal right here, as long as I keep it as far in as I can, I'll keep the gauge roughly the same, and you probably won't even tell the difference. So again, that's the plan. Next video, I will probably get into working on these hubs, or I'm sorry, spindles. We'll get the holes drilled, I'll get the round stock in, we'll start getting that mocked up. Something else too, I need to build in the camber for this front wheel. So camber is basically the measure of how the tire leans like this when it's installed onto a tractor or even a car or truck. But I think I want to have some positive camber built in, meaning the top of the tire will be tilted outward just a little bit. That just makes handling a bit better and steering, especially for a tractor with tri-ribs and with the heavy front loader on it. So I think the original camber, or the spindles, were bent at roughly 102 degrees, so about 12 degrees past 90 degrees. So if I go at 102 degrees, that should make the tire perfectly vertical, I think. But again, I might go a bit more and just tilt out that wheel a few degrees more. That's the plan anyway. I might do some more research on that to see what the perfect, or what the more proper angle is for the camber for something like this. And then yeah, we'll move into machining out those spindles and moving on. So again, I appreciate you guys watching. I know some of you are probably not liking what I'm doing here, but without having the original Danco style heavy duty front hubs, of course that's my first option. Of course I put those on here, but this is the next best thing. I think I'm doing this tractor a bit of a favor, maybe kind of upgrading this front end here. Now the easy way out, I could have just bought brand new rims, because these ones were sort of blown out around the bearings. But I think this is a much better long-term solution. Yeah, we have some work ahead of us here. Definitely some machine work. It'd be nice to have a mill, but like I said, we'll try the drill press for now and see how it goes. So as always, I appreciate you guys watching. Hope to see you back here again.